think we are we live? Oh, I'll never get used to all this software. All right, I think we are live. Somebody send me a message. Say, yes, Bill, you're alive. Look, we made it another day, Kevin. There we go right here, bro. All right, hopefully everybody can hear us. I'm running so much software on this laptop. It's crazy. Thanks for coming back. All this stuff is being recorded.
Yep.
So if I could get Kevin to just take a breath. I've got him busy. It's my fault, right?
Keeping me busy, Bill.
We're writing a lot of code here, so trying to get some cool stuff done. Like we've got the new exam site that's almost ready to go. Actually, we can show that, can't we? Let me see here. I got to go to screen share, don't I? Here we go. Look at that. How cool is that? So it's not ready yet, but this is some stuff Kevin and I have been working on. So very soon, you'll be able to be Go and Rust certified. We have a bunch of mics might be a little low, they said. A little low. He said the mics might be low, so I don't know if there's a way to turn that up a little bit. Trying to keep that mic out of the view there, so I don't know how to make it even louder if I wanted to. I guess that would be in the system settings for the Mac, right? Let me see. I think I have it all the way up already, though. Yeah, I don't even know. We'll have to play with that a little bit more. But as long as you can hear me, we're good there. Yeah, but the mic gain might be crazy.
Let's try 23.
All right. Tell me if that was better or worse, Jeffrey, because I don't really know. I'm going to keep it there for a minute, and you tell me how good or bad that is. But what was I going to say? Yeah. So we've been working on this. I think we're like, hopefully next week.
Mm-hmm.
If you try to touch anything there, though, it's all test accounts. So, but that's sort of coming, and we're adding some cool AI search features to the homepage. So, pretty excited about that. But that's what we've been sort of working on. So he hasn't been able to edit the video yet. But next week we'll have these 2 videos up and running.
Yep.
Again, if the mic isn't good, let me know. I think we've turned the gain up. I don't know if that made it better or worse. Hopefully better. And I'm just looking at lights there. Yeah, I mean, I see like 2 or 3 lights. So, all right, Jeffrey didn't say anything else. So we're going to keep going. Hopefully we're good there. All right, so this is the hardest part of doing this every couple of days. You have to remember where you are, right?
Yes.
And this week I've been working on like 2 projects literally at the same time between you and Jacob. So talk about that. You know, one thing I'm always telling, let's see if I can get back here for a second. Kevin, let me get back here. You know, one thing I'm always telling Kevin is this is like a game of chess. So you've got to try to keep the entire code base, or at least the portion that you're working on, in your head, right? So you're constantly playing chess against everything that could go bad, not necessarily good. And this is just something, again, you're not going to learn in university. This is just, it takes time and experience to kind of know what should be in your head,
Yep.
what shouldn't be in your head. And I would say the biggest problem I have with Kevin when we're doing things is he doesn't stop me and to say, Bill, I don't understand.
Yeah.
Right? To the point where I start realizing he doesn't understand. I'm like, tell me what we're doing. And then he can't. And then I'm like, okay, let's stop and reset. I don't know why you do that. What happens? You're afraid to tell me that you don't understand what's going on?
I get sucked into writing the code, and I'm just like...
Yeah, but you can't write the code if you don't know what we're doing.
Yeah.
Right? I know when you have no idea what we're doing because you freeze.
Yeah.
And I'm like, okay. But, right? And then I have to reset you. And then at some point you're like, oh. And I'm like, I want to strangle you because you should have been at oh like 3 minutes ago, right?
Yeah.
So, like, I'm learning how to read Kevin's body language and typing and stuff. But you literally have to say, I don't understand. Like, it's not a bad thing. Yeah. If anything, that's on me because either I'm moving too fast or, I'm not explaining things well. Because remember, I've got the whole chessboard in my head.
Exactly.
I'm already 3 moves ahead of wherever I'm at, right? And you're not there yet.
I'm trying to make my board. Right
okay, you're trying. So even as we do this, right, even though I'm driving I'm driving on these. Maybe one day, maybe like in a few shows, we'll switch. You can do some driving here.
For sure.
Because it's completely different when you're driving as opposed to I'm driving. It's easy
100%.
for you to go out. But let's at least get this to a certain point. Plus, as we work every day together, I'm watching you drive. Your driving is getting better, actually.
Yeah.
So I think once your driving is at a point where that's not slowing down what we're doing here, I think we can do that. But you need to say, I don't understand, right? You need to say, and I'm rough. Like, thank God Kevin can handle me. Because sometimes I even know my tone is bad. I'm like, oh, I shouldn't have said it like that. But, right? I mean, sometimes my tone's bad. He's got a tough dad, I think. So his dad, I feel like I was talking to Ali, and I'm like, sometimes I feel like my tone with him is bad because I get frustrated. And he's like, yeah, but I met his dad.
Yeah.
And I think his dad talks to him the same way. So he doesn't.
I live in the same house as a firefighter. We're okay.
Yeah. All right. So let's figure out like where we left off yesterday. Also, some people said that they wanted us in view when we were in this mode. So we just got to make sure we're not. I think the top corner will be good for. We can even make this smaller.
We could.
Can we?
I think we can make it a little smaller.
I think that's better, right? I mean,
Yeah.
Don't have to be that big. That should be good enough. Okay, so let me let's get back to sort of where we were. Let me bring up the code here. There we are. Okay, so I think that last week we were able to get this endpoint up and running, right? Let's do a quick read of the code. I'm somebody who likes to read code from top to bottom. I'm trying to teach Kevin how to do that because if I can teach Kevin how to do that, well, I'm doing it mainly because it helps me sort of also reset my mind on what the code is doing.
Yeah.
Especially if I start to get lost. If my mental model starts to, right? I can't keep the chessboard in my head. The best thing to do is to just start reading code again from top to bottom. And the professor asked here, I'm new to this and I find your web package a bit complex to understand. Could we go over quickly to clarify? So I'm not going to go over that right now, but this is where I have like my service class that I teach, and we've got sort of videos out there for that sort of stuff where we write it from scratch. And yeah, I mean, that web package, you're looking at code that's several years old that we've adapted over time for very specific reasons. So I think the best thing is for you to reach out and I'll figure out how we get you access to the Ultimate Software Design 2.0. And that's where you can see how that was sort of built from the beginning and why, right? I mean, that would be an entire thing, and I don't want to necessarily do that here. So I'm going to drop my email again on this thing, bill@ardanlabs.com. So just ping me on my email and we'll figure out how to get you that information there. How long is it on already? We're only on for about 8 minutes. Okay, so I know we've got the chat run working. We've got the chat test working. Let's just quickly review what we're doing. For anybody new here, I want to keep all this stuff in one repo. So we're going to have different folders for the different apps that we're building and work our architecture here. Normally this stuff like API and app would be at the root of the project, but we're not going to be doing that. Also, if somebody can let me know if the mic is a little bit better, if you're having troubles listening to us. I could always put the mic in view, but Kevin's very anti. We're going to need Eric to be the boom, right? Yeah, Eric, you got to be a boom. All right, let's go and look real quick at what we've got here. So we're calling this service CAP for client access point. Let's go back to the diagram for a second. So this is, we're trying to build the initial CAP, our client access point. And the idea is it's going to be a Go service that will accept, see, everybody's saying that the volume's a bit low, dude. We should just bring it in. Like, who cares? I mean, personally, I don't care, but why can't I? Oh, I'm over here. Yeah, just bring it in. Who cares, bro? It's no big deal. Like, it's not my way. It's not in their way. Here, Kevin has got to be closer to me. That's fine. So that's fine. Everybody, hopefully that helps the mic a little. That should be better. I put the auto level's always better here anyway. Okay. So back to everybody saying volume is low. Oh, far. It has to be far. Oh, how's that? Mic, I forgot. It's my mistake. I had the mic on a near setting, not a far setting. So hopefully that is better right there. Okay. So we're going to come in and we're going to say, yeah. It was my mistake, everybody. I had the near setting on, not far setting for me. Plus, again, we'll just keep the mic here, dude.
We'll
Who
just
cares?
keep it.
It's more important that they hear us than the aesthetics of that. Okay, so let's go back to our diagram here. So we're trying to build CAP. We're trying to make it so we can get a WebSocket in there to get connected. And we've got to think about mapping WebSockets to different people and then being able to route that. And right now, we just want to get it to work. Just here alone, right? Like that's our initial goal. Once we get that working, then I'm going to bring in a NATS expert. I'm going to try to get David Gee, and he's in the UK, but I'll get him to come in with us here. We got to figure out how to bring a third person into this with like on a Zoom or whatever. And then we'll introduce NATS on how we could leverage NATS to route between these different sort of caps. And then we'll make some other decisions. And I think we left off last week or 2 days ago with getting at least an endpoint working, right? So a big thing for me with this main function is that we don't want to hide any initialization. We want to know where things are being initialized, and we want to know where things are coming from. We want to pass those things around the program. We don't want to hide things in context. For sure, we want to minimize, if almost eliminate, any sort of singletons. Singletons is when you have something that's constructed at a package level and you can just access it through the package name. Okay. Sometimes you're stuck doing it because the API design for that package was a singleton. Like OTel does this. Some packages give you the option to have both, like the log package here. There's a singleton aspect of it. In fact, you were almost accessing it yesterday because you started typing log dot. I mean, think of the mistake there because you were in a method. Yep. The log was part of the receiver variable, but you didn't know that, and now you start using another logger because the log package has a singleton. Like these are and you're wondering what's going on eventually. Yeah. So again, we just want to stay away from that. So we're constructing a logger using our logger package that uses the structured logger from the standard library. And then we've got our run function for initialization, startup, and shutdown. And that way it can just return an error. We've done a little config using the Ardan Labs config package where we can set defaults and sort of overrides. Right now we're just doing the web stuff. So we've got some basic timeouts. We parse that in. We've got some logging for startup. We even have some sort of build information that the Go compiler gives us. And then the big thing here is that we're going to use an HTTP server to launch a web service, right? And that's parameter here, the handler, is for the mux. And we remember we were passing nil at the end yesterday, which is why we were going crazy trying to figure out why it wasn't working. And somebody on the call was like, Bill, you're passing nil here on Web API. But the Web API's job is to initially create the mux and help us bind all the routes to the mux, and then everything would work, right? All this is HTTP stuff. So we create a server. We've got a Go routine. It listens and serves. If anything happens, it fails. We'll get that error back on a channel so our main Go routine can receive it. And then our main function basically blocks. It has to. But our program blocks here waiting for a shutdown signal. In our case, will be a control C. In an orchestration environment, that would be a sig term or something, which is why when we create this channel, we're saying sig term. Sig int would be like the control C. And then, so that's like the main Go routine, right? If I were to draw what we're doing right now, let's put this aside for a second. Ideally, what we've got is the main Go routine here, GM, main Go routine. And every Go routine is a path of execution, which is why I like to draw them this way. So there's a path of execution here. And ideally, this path of execution sort of stops until we're ready to shut down. And the job of this path of execution right now was to create another Go routine, right? We can call that maybe we call it our GA or something. And that's that application go routine to handle that mux, right? So now we got another path of execution. But this is essentially implementing that mux or managing the mux, right? So we've got to initialize the mux, which is all the routes that we want to expose. That way, when we get some sort of traffic into our system over HTTP, like that test route that we built, right? That traffic connects into our app through this mux because we're listening on that particular port. And then what's going to happen thanks to the H package is it will create another path of execution or another go routine that at this point, this go routine's job is to handle that request. And we can have tens of thousands of these things happening, right? And the idea is that when it's time to shut down, we need to wait for all of these child go routines to finish. So to have a quick sort of concurrency conversation, and this is why I got Kevin on the call here, because with Kevin, I know he doesn't know any of this stuff, and so it makes me need to sort of talk about it, right? So imagine we had 10,000 of these go routines per executing requests.
Yeah.
And let's imagine, like what we've been coding this week, these go routines are reading databases, but more importantly, writing documents. Yeah. And suddenly this go routine shuts off. So the moment this go routine terminates, or the main function returns, the go runtime can't be a zombie process. It's just going to start killing these things.
Got it.
What if it's in the middle of, we wrote some things that say, do this, then write this, then do this, then write this, and you cut the legs out of this go routine right in the middle of that. What happens?
It's gonna.
We have bad state. Not going to blow up. It's going down. But now you only partially wrote to the database, as opposed to finish it. You have corruption at that point, as far as I'm concerned, bad state, which now is causing other bugs that may or may not be obvious. So when we deal with go routines like this, what I'm always going to be thinking about, what I want you to be thinking about, is that there are parent-child relationships. Everything's a parent-child relationship. This being the patriarchy in a sense, right? Because this is the main go routine here, right? This is the head of the household here. So if you think about it, this go routine is a child of this go routine. We know that because if I look at the code again, we see that it's being created, right? Yes. It's being created there. So, however, this go routine is really a child of this go routine. And so there's always a child somewhere. And technically we can say that this is the child of the go runtime, but in our programming model, that's origin, right? This go routine main is the origin. So when this is managing the main function, so we can just believe in our programming model that when this go routine is going down because the main function returns, the go runtime is just going to start killing these things off. Bad. What we need is, if it's time to shut down, this thing here needs to wait. It needs to wait for those child go routines to complete. In general, it's best when the child go routines terminate before their parents. And that the parents,
the main function returns.
Oh, anything, right? Even these child go routines need to terminate before this. So if this go routine needs to terminate, it should wait in general. You can't always do that. There are times where the parent go routine needs to terminate before its children. I call those orphan go routines though, because their parents gone. And you can't have orphan go routines because now you want to shut down and you don't know about them. So at the end of the day on that, what you need to do is establish the step parent.
Got it.
So you can't have an orphan. If you're going away, you're responsible to give these kids to somebody else. A lot of times it's this go routine takes over, and this is done through a package API, like with a shutdown call. We'll see that at some point. So anytime I'm looking at this sort of concurrency code, the first question I'm like is, are we orphaning? Are we orphaning? Are we orphaning? And we're not really orphaning here at all, because here's the go routine. We're using this channel to make sure we don't orphan, because when this go routine terminates, we're going to know about it right here. There's an orchestration mechanic here. So at the end of the day, we're holding the main go routine. We're waiting for a shutdown. And this shutdown call takes a context. It says how long you're willing to wait. Won't have this go routine completely terminate until all the children for a certain amount of time. You can't wait forever. Yeah. And if that time is over, then we are going to have to cut the legs out. So we have to be smart at some level about how long we're willing to wait. As a default right now, I'm using 20 seconds. I don't want these timeouts to get in my way, but that might be too long, might be too short. Somewhere we got to come back and sort of figure that out.
Yeah.
Right? So we've set all this up, so we now can start handling some routes here. And we set up the one route. Again, we set all that up through our Mux package, which is an app layer SDK package. And the Mux package has this one function call called Web API. We give it a config, value semantics. So here's the general rules for the data semantics that we're going to use. Anytime we define a struct, we're going to ask ourselves, does this struct represent pure data or does it represent an API?
Got it.
Configs represent data. It's the config that we need in order to initialize something.
Yes.
So we should be using value semantics when the struct represents data. We should be using pointer semantics when that struct represents an API.
Okay.
So we're going to use our web package. We're going to construct a new Mux. We're giving it that middleware that we created, the logger middleware, some errors, panics middleware. And then we have these app layer domain packages that represent the set of routes for a given domain of functionality. We've exposed a route function there. And notice here, web app is using pointer semantics. Why? Because that represents an API. If we look at our app layer, what is it using? Pointer semantics. Why? It represents an API. This API is the set of methods or handlers that we're using. And so all we did here was say, okay, let's route via a get /test. And if /test comes in, then we're going to execute this function here. And all we're doing is returning a status. And like somebody was asking about this being a little complex, it is. There's a lot of reasons for that over time. But again, the service project, the service class, it really explains that in more detail. We just had to implement the encoder interface, which knows how to encode itself. And we did that. So if I go back to the terminal, what did we call the command? Chat run. So if I do make chat run, now the service is running. And if we do that make chat test, boom, it hit it. We had the logging. Now, this is bad, actually. I didn't notice this last time. We don't have the unique
We don't have UUIDs.
trace ID. Whoa. I know we put code in that for there. So I need to, let's take a look at that, because to me that's a bug. Now, that bug would originate from, let me get back here. That bug would originate from here. So the idea is that our logger takes a function that is called anytime it's supposed to get the trace ID. And you could see here that this is part of the web package. And if it can't find a trace ID, then it returned the empty UUID, which is what we're seeing.
Yeah.
And that shouldn't have happened, because if I look at route, we're using handler function to bind the route. And, oh yeah, dude, we forgot to add a UUID to the, I thought we added this, didn't we? But we never used it. We never used it. So this version of the web package is slightly different from the service one, right? Because we took all the OTel out.
Yep.
And the OTel tends to give us these things. So the mistake that we forgot is to use the set trace ID, right? Which will take that context that we got there. And then we need to pass in a UUID. And in this case, we can use UID. I'm going to have to open the door because my dog has decided that he wants to participate on this call here. So we're going to, if we do that, then we'll have our trace ID. Hold on. Yes, I'm in. This is what happens. This is what happens when you're live. You got dogs wanting to go in and out of the house for some crazy reason. Okay, So we need that UUID here. We have it there. So, oh, but it's not new string. It's just new, right? Okay, because we wrote that API to take a UUID. So we forgot to do this where we were setting it even with no mid. And I think I have another one here, which is a raw handler func. But a raw handler, I don't remember if a raw handler func has middleware associated with it. Oh yeah, it does right here. So let's see, we'll just do that here too. Okay, so I think that solves that problem. Let's go back now and restart. Run it, run this. All right, there it is. Now we've got, now it's working here. So we added the API, but then we forgot to go in and sort of use it. So the next service live actually is happening next week. Yeah,
okay.
But it's early. It's like 8 a.m. to noon every day because there's some people from Europe that are going to be attending. But everything's also been recorded, so it's easy access to that. Okay, so we fixed that little buggy bug here. We had this working here. We kind of went back through main a little bit, and we've got that. So let's do the following now. I think we've got a good. Now look how long that took. It was like a 20-minute, right? Yeah. And this is what happens when you're constantly having to sort of context switch all day.
Yeah.
You know, you lose 20 minutes just to get your head back, to get the chessboard back in your head, right?
Yeah.
And so it's really hard, especially when you're being pulled all the time, right? You try to just focus, and then you just know if I do this, I'm about to lose 20 minutes.
20 minutes of
to come back when I get back to this, you know. It's really hard in marriage too. Like I had to Allie, you know. I've had to say to Allie, I go, I know you need me right now, but unless it's like super critical, if I stop, right?
Yeah, you're gonna be lost.
I have to take the chessboard out of my head, and then I got to get it back in my head, and it can come across. So
I do the same thing.
No, I know, but it's like you got to have that conversation, right?
Yep.
Like if it's really important, then stop me, obviously. Mm-hmm. But if it's not, like, let me just stay in the zone. You know, I was working one time, and when I was working on the book, I used to go to a bar every night because I couldn't go home. I had the kids there, and my wife always had a rule. My first wife always had a rule. If I was home, I couldn't work.
Yeah.
So I would go to this bar. I wasn't drinking like every night I was there. I had Coke and stuff. I was working on the book. So one day I was working on it, and this waitress, she was new, because I knew the whole staff at that point. It was like 6 months. She came over, and she's like, I didn't want to bother you. You looked like you were in a trance. And I was like, yeah, I was in the zone. Thank you for not bothering me. She's like, that was scary. But then I've had other waitress people there that were like bothering me every 10 minutes. Do you need something? Do you need something? And I was like, oh, leave me alone.
You're just there for a workspace.
You know, leave me alone, leave me alone. So you can see, we lost 20 minutes on that sort of review. But I said I wanted to push this code out. So it's going to be just basically that little bug fix for trace IDs. All right.
And for people who may have joined in and missed the beginning, they can follow along with us, right, through the commits?
This commits, yeah, you can always detach to a commit too if you wanted to. But ideally, if you pull this down, then you have exactly what we're running locally, and you just need Go installed. You know, there's another patch version of Go that came out this week, but I haven't switched to it. And I think we're in 124 RC3. So probably by next week, we're all going to be upgrading to 124, and that will be fine. But we won't change the Go mod here. Whew. Okay, so I did see under our app domain package for the one route a bunch of things we left. Now these comments were good, right?
The to-do list.
Yeah, yep. Because I wasn't going to remember any of that. All right, so we need to implement our WebSocket, perform a basic echo, make sure we're handling. Okay, so instead of calling this test, maybe we can call this Like, so I never want to be paralyzed when we're naming something, and it's not obvious to me what to name it. So the first thought that popped in my head when I paused was connect.
That's, yeah.
But this is going to be doing more than just connect, right? Like you're going to connect, but we're going to stay in this handler. There's going to have to be a loop in there where we're getting data and at least sending it back out here, as I remember. We won't send it. Well, we'll receive it here for sure. I doubt we'll send it here, but we'll receive it here for sure. So connect feels a little too specific to what this is going to do. So maybe right now, even though it's a chat package, right? But this is maybe, I don't know, man. I don't like any of it. I know I don't feel like connect is, I don't know. Well, let's keep it connect for now. And then when we learn more, I think a better name will come up.
Okay.
When I'm completely clueless, because we're really starting out, I would have just called this Bill. And that's just me saying, you know what? I really don't know enough. And I don't want to be paralyzed by it. And that forces you to go back at some point because you can't leave it.
Exactly.
Right? Like I could leave it connect and maybe get away with it, but I could never leave it as Bill.
Yeah,
right?
you have to go back and
I have to go back. Somebody's going to look at it and say, what are you, like, you full of yourself? You name things after yourself, right? Like, are you schizo or something? What's going on, man? No. So let's start with connect. Let's start with connect. And I don't think it's going to stay connect, but let's sort of start with connect. And remember what I said to you 2 days ago and anybody else that was here. All the code you've ever written is part of your toolbox.
Yes.
Right? Like all your experience and all your wisdom and all of that is part of your toolbox. Any third-party packages that are out there, people are adding, giving you free hammers and screwdrivers and stuff. But all the code you've written over the years also is part of that toolbox. And that's where I pull a lot of code that I need for another project. That service repo is a big toolbox for me, and that's open source. The blockchain project is open source, and I did some WebSocket stuff there.
Okay.
So I'm going to bring that project up because off the top of my head, I don't remember. I don't want, like, my brain is full already. So I'm at a point in my life where I don't have the information in my head. I just try to retain an index to where it is.
Where stuff is.
If I can do that, I don't feel so bad. So but this is where I really start to break down. So I was on a stand-up today, and this guy, Ed, a prediction guard, he looked like Ben Affleck today. He had the wool hat over his head, and he had the beard, and he, but I couldn't remember Ben Affleck's name. Like, I had a picture of him in my head. I wanted to make a joke to Ed that he looked like Ben Affleck. But I'm like, who is the guy? So the Google search I did is writers for Good Will Hunting.
Oh, okay.
And then Ben Affleck. Okay, boom, right? Like, that's my brain. It sucks. Like, I couldn't remember Ben's name, but I remember that he was. I knew he was a writer for Good Will Hunting, and I don't know if that's everybody. I don't know if it's just me. I just feel like my brain is on overload.
I do the same thing. I'm good with faces, but not names.
No, it's horrible, right? So eventually, when I want those glasses you see in the movies now, where it can just tell me everything that's going on somehow. If I was a president, I'd have somebody in my ear all the time, like with the glasses. Who's this? Who's that? So you look cool, right? Like everybody feels good. Yeah. If the glass technology got back, eyeglass where you could spend a couple $100 and it had a decent API, I'd start playing with that sort of stuff, right? Because look, all this AI now with the images and stuff, it could bring up Kevin, blah, 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 blah. Dude, that would be
that would be some
no,
crazy
that
stuff.
would be badass. Okay, so I'm looking for the WebSocket code that I had here, and I think it's here under some public stuff. And let me see. This was events. See, WebSocket upgrade. So in the blockchain project, I wanted to get these events back and forth between the different games. Like, you needed to know when the other person played their hand.
Okay.
So I thought, let me play with some WebSocket stuff here for the first time. And you can see here I'm using the Gorilla WebSocket. So let's sort of move into programming mode here and get a WebSocket just connected, echo. None of this will be very good engineered code, but once we get that working, then we can look at it and go, okay, what do we know? What don't we know?
Exactly. We'll have a better idea.
We'll have a better idea of what to sort of do. So I can say at least this. We're going to need a WebSocket, and we're going to use the Gorilla one for just because I've got code that works with this.
Yep.
And then we'll have to do that back here. We'll have to do that make tidy. All right. That brings that in. So, and this is like a WebSocket upgrader. So I imagine that there's something in the client connection that happens that is able to be inspected that says, oh yeah, the other side wants to speak WebSocket too, not just like straight HTTP. And now there's this new streaming, right? SSE, I think they call it.
Yeah,
We could have played with that too a little bit, but this for me isn't necessarily about. I just want a WebSocket, I think, right now because it's simple, and we can do it in JavaScript if we wanted to. That could always be ripped out. You could always provide different protocols for this too, right? So for me, it's not the biggest thing. Now, we've already done the core stuff in our little web framework, right? But this feels like the next thing that we'd have to do in this sort of thing here. So this would be A instead of H, right? And now we need the request. Now, because of the way that I've implemented my web framework, trying to have guarantees around encoding and stuff, this isn't a traditional sort of, right? But we need the response writer. So that's not a problem because the web package that I wrote allows you to get the writer from the context. So we need a context. So we can look at that code real quick. So we set the writer in all of these different handlers. You know how we just set the trace?
Yeah.
We set the writer in there.
Okay.
Most of the time, I don't want people pre-writing data back to the client. Remember, I wanted this respond to write the data. I just want people, in this web framework that I have, I just want people returning objects back to the web framework and let the web framework do everything.
Got it.
It just makes the handlers a lot cleaner, right? Because all you had to do was return this. As long as it implemented an encoder, the web framework knew how to convert it, in our case, into JSON. Nice and simple, right? You don't have to think about these lower level things. Plus, if you wanted to now not use JSON or something, you have other options. You're detached from how you're encoding data. These were experiments and things over the years. But in this case, we have to control what's going on. Now, I could, because this is going to be so raw, right? We could also choose a raw handler func. It does still take middleware, and this is a traditional response, right? A function that takes a response writer, sort of, and that. So we could also do that, and we'd have access to the response writer directly. We would be responsible for all responses there. See what's happening here? And maybe for what we're doing, that's sort of better because with this WebSocket, yeah, right? I'd have to send a no response for this to sort of be ignored. So maybe what we want to try here, let's try it, is we change this to a raw handler func, all right? A raw handler func has this signature here. So we come back here and it's just this. All right. Now, one thing I want to know is this. All right. So in this raw handler func, you notice the first parameter isn't a context. And I might still need the context. So what we've done is wrapped our little handler function with another one here, and that is setting things up in the context as context. So R equals R dot with context. You get a new R, which is a new request, and then we'll execute things that way. So what that means to me then is we should have, everything should still work there. But by doing this, okay, now we'll have our ability to do an upgrade. You can't return an error back. So we've got to be, this is raw now. Now we've got to be raw in what we want to do if we're unable to. See, this is why the other handler was nice, right? Because I don't have to think about this.
Yeah.
I could just return an error and format that. Now I've got to do some extra work. So, you know, it's the beauty sometimes of the things that you're writing. So maybe now, just because I started seeing the error stuff, we still got to deal with this, but it will be easier to deal with it. In other words, now what I can do is use the errors package, say a new error F, and then we can now just say the errors package dot. Now we couldn't upgrade this, right? So it's not an invalid argument. Maybe it's a failed precondition. Or it's not. It's no. Even though failed precondition would be more sort of data, right? Indicates the operation was rejected because not in a state. Well, that might not be bad one. First use. I wonder what that gets mapped to. Failed precondition. Oh, okay.
Bad
So
request.
it's a 400.
Okay.
That's fine. All right. So we'll do that. And then in our case here, we already have an error. But instead of sending raw information about this failure, right, maybe we can just say unable to upgrade.
Yeah. Failed upgrade or
Upgrade to WebSocket. I don't know. I don't need anything else. That's good for now. But again, having our higher level handler sort of lets us do that really nicely. You know what I'm saying? Okay. So the upgrade takes the writer response header. I wonder what the response header in this code too. I just passed nil. Okay, that's fine. So either we can't upgrade this sort of, or we can't. Okay. So what's next in this event thing here? So the next thing is start a ticker to send a ping message, right? So when I was learning the WebSocket stuff, we in order for both sides to know that they're still there, right? There's this sort of ping mechanic.
Okay.
So I think you get to set how long you're willing to stay connected without hearing from the other side. And so this isn't like real data we care about. It's just more, hey, are you there? It's like a ping.
Yeah.
It's like me punching you in the arm and you going, yeah, I'm here, stop. Yeah, no, I'm here. Like, right? Like, so we've got that. Now, it looks like what I've done here, let's bring this in here for a second, is I've defined a ticker and I've said that every second this ticker will go off. And then it looks like what I've done here is gone into an endless loop. And at this point, I don't know what this channel is, so we'll deal with that in a second. But if the ticker goes off, there's the ticker. So if we're in this and this goes off for that second, then we're going to send a ping message.
Okay.
Because C, which is what we got upgraded to, it's our WebSocket connection here, has a write message, which takes a message type. In our case, it's a ping.
Yep.
And it will send the ping. And this will be, hey, we're still alive, we're still alive, we're still alive.
Got it.
This piece is the interesting one because that writes sort of a message back. And this is the piece that we've got to code for that echo thing, right? We're going to receive and we're also going to write. So we've got to look at the, it looks like I only implemented sends in this in this blockchain thing. I'm only sending. I'm not
Okay, you're not receiving.
receiving. So we're gonna have to figure that out here. Yeah, because the idea, this is an event that occurred, boom, right? But I also like having everything in one place. So this idea that there's a channel that we can send a message on and then send it back to this connection, it's kind of interesting. We don't necessarily need to do that if we create our map and we keep this sort of WebSocket connection with that map. Then we could technically do that from anywhere. I do have the close here to close it down. And so at this point, what I've got is the request go routine, right? So I'm playing chess right now a little bit on what I want to do here. But what we've got right now is the idea that they called connect, and this go routine doesn't terminate until there's an event that causes it to terminate. And it's also sort of doing the send. I don't know if I like that right now. I also don't know if I want, well, most likely if this returns, it would shut it all down. So I think we're gonna have to hold this, right? My guess is the HP package, if this returned, it would drop the socket connection on the other side. So I think we're gonna have to keep it there. For this right now though, I'm just gonna do a new no response. And that just tells the web framework, you're not doing anything when it returns here. Now this is unreachable code, so we may not need it at all. I'm trying to think a little bit right now what we want to do when, you can see here we're checking if this channel is closed, then we're releasing the WebSocket. So that's just returning, essentially this should be returning a no response here. This should be a no response here. We should have some logging in there though. We may have to bring the logger in. And if this happens, we should test to see, again, I don't know if we can send a response at that point. You know, this was a raw event, so it would be interesting if we sent a message or something there. So we're gonna have to play with it. There's a bunch of little things that I don't know. I don't know if I wanna send an error. So, you know, doing something like this here, right? Unable to send. I don't even know if that gets back all the way back to the client, right? So, so these are little things that we've got to figure out. I have no idea. We're gonna play with that. I do know one thing though. The code that we just found is only to send a message. It's not to sort of receive the message back. Now, I'm wondering, we're going to go look at the API design, but sometimes what I might just do is just this real quick, right? Because you can see there's a read message here. So read message is a helper method for getting a reader using next reader and reading that from the reader to the buffer, right? But this is bad for me because it's not telling me, is this a blocking call? Is this, what are we doing? Right? We know we're server side, so, but it doesn't mean that we need to wait for a read to do a send either. So we might have to go to the Gorilla stuff, and here's the next reader. Next reader returns the next data message received from the peer. It returned a message type is either a text message or a binary message. There can be at most, so it looks like we've got to do a next reader and then we can do a read, right? Though it returns the next data message received, though I see a reader there. There can be at most one reader on a connection. That's fair. Next reader discards the previous message if the application has already consumed it. Applications must break out of the read loop. This method returns a non-nil. So this is making me think that we need another go routine that will essentially maybe block on this. If it returns an error, maybe the socket connection is sort of dead, right? Like I'm starting to get that.
Okay.
What I hate about this message though is that it's not telling me if it's a blocking call. So my guess is that it is a blocking call. All right. Let's read this one again. For getting a reader using next reader and reading that from the buffer. So I'm going to do this. I'm going to just sort of go in here. So look, it's already calling next reader, right?
Yep.
Then it's using an IO util read all, which is deprecated, but for our purposes right now, that's okay. And then it's returning. So this is doing both, right? We don't have to do it ourselves. And it will return an error if this errors. Let's quickly look at this function. Because what I want to know is, so here's a loop. It stays in this loop until read error is nil, or while read error is nil. Does some advanced frame. If there's an error, breaks out of the loop. It does this, constructs this. It does sort of this, and then it returns. My guess is that's going to be a blocking call. And then error, don't have to handle, this is all unexported stuff, right? So let's go in here, because this is a loop, but it will break once this is true. If not, it goes back into advanced frame. Let's go in here. C reads remaining. Bop, 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 bop. There's a call to read. Set reading remaining. There's a switch. There's a bunch of notes. There's a big function, huh?
Yeah.
And what's a bummer again for me is there's no real sort of information here, right?
Yeah.
Telling me much. So now I'm curious what this looks like. Now this is a call to peek. Peek returns the next n bytes without advancing the reader. Byte stop, next reader call peek, fewer n bytes, blah, 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 blah. Calling peek, succeeding. And then there's sort of a discard. And not much going on. So this peek I don't think would necessarily be a sort of blocking, but it's looking to see if there was anything going on there, right? So no frame, set bytes and many. I mean, we could jump into the code for Gorilla just to triple check some stuff here. Because at some point, yeah. Let's do that anyway. I mean, I know we've looked at this code here, but I'm getting a sense that we can be in a loop with this, similar to sort of what we did here with this, okay. But why don't we just quickly Golang Gorilla WebSocket read message. That's what it was called, right? Read message. And this Gemini thing kills me. Look how long it's taking. Oh, couldn't do it anyway. So this is the
WebSocket docs.
So here's a chat example.
Perfect.
Right? It should give us some sort of thing. So let's see, that's client hub maybe. So look at what they did here. Type hub, blah, 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 new hub, yada, da, da, da. Then you got to run. And then what is it doing here? It's endless loop, blocking on a channel, register, unregister, sort of broadcast, and client send. I don't really see what I wanted to see here, to be honest with you. Broadcast, register, yeah, this is weird to me. Maybe this isn't this example is kind of not what I'm looking for, I don't think. Let me see client server example. Here's a server. This is going to be better. So here's the echo.
Yeah.
So there's our upgrade. There's our close. Look, so it's in a loop and it's in a so that's definitely then going to be blocking. And then it's just sort of echoing it back, right? So that's what I expect. That's what I assumed, right? That the read message was sort of a blocking call. So that's good. So if we sort of come back here then, what we could do here, that's a blocking call, right? So let me tell you where my head is right now, sort of where my head is right now, because we're in this sort of go routine.
Yep.
It seems to me that we're going to need a go routine to handle, this is our go routine, to handle our, call it our receives, right? And then we're going to need, the question is, for me, and I don't know the answer yet, do we want a go routine that handles writes, right? So let's just call this, to make it a little simpler, reads,
Right.
writes, right? So we do it here. And what would happen is if this does a read, right, we have, remember what we said over here? We wanted this sort of router and map socket per thingy. So let's just say that we had a package here that's listening on a channel. So when some data comes in, let's just say its job is to pull it and send it here. All right. And then the job of this is to do that little sort of figure out the routing. And then if it knows that it's supposed to go to this client, it can just send it there in a general sense. I put this here, so I do this here so it's not on top of my circle there. So this is one way that we can do it, right? And play with a little bit more concurrency where that go routine just reads and sends data. I like these sort of single purpose things.
Yep.
Then this just receives something and writes it. It's sort of blind. It doesn't know what the data is. It doesn't particularly care. And then we have a package here that gets it and then can send it. And we could do this with channels. I tend to like functions. I mean, this part could be done with a function, the read part, where what we do is we expose an API, little API here, right? That says message received. And then what this will do is just execute that API. It's super simple, right? I don't need channels for that. This one is harder because we have two choices here. This thing could call write message on the socket itself. All right.
Okay.
So in other words, what we could also do is if this thing had the socket information, which it will, okay, it could do the socket write. So we could have this do the socket write. All right, because it could have it already and it just knows this message came in for this person. Here's my map. There's the socket. Just send it. And it could do that. Or it could say, I know that this is the Go routine that's managing those writes. And it can just do it like that. There's advantages and disadvantages to both. I'm somebody who tries to avoid the channels.
Okay.
If I can. But I'm wondering, because we have to hold this Go routine sort of hostage anyway for the reads, that if we also just have it do the writes, it's all in one place. Sometimes having everything in one place is better for mental models. Yeah. So if this is where the socket reads are happening and the socket writes are happening, then this is the only place we have to go if there's a bug.
Okay.
And then all this has to do is if we have a bug, it's because maybe we didn't send it to the right sort of thing. And so all this then needs is that sort of map that maps basically a socket to some person with the channel that is there. And then all this can sort of work. And then we'll have essentially, we'll have this loop here where we read and write. Here, it's easy because we're not going to write unless there is something to write. And so maybe what we end up with here, I'm hacking, terribly hacking right now. See, that's kind of cool that, I think it's kind of cool that it knew what I was somewhat thinking here. You've got to be able to terminate this thing, which we're sort of able to do here.
Yep.
But, and again, this would really have to be more of a go func. This is not the code we're ending up with by any stretch of the imagination, okay?
Okay.
I'm just playing a little bit in my head here. So we've got the ping go routine here. We would have I need a read go routine.
Yep.
So some sort of, not bad. Let's just throw it out. I mean, Copilot's, I don't want to do the write though, okay, which is the problem there.
We just want the read.
We want the read because we want to send it somewhere. And so you got your ticker, you got your read, and then you've got your sort of writer. And even for the writer now, like we don't really need, just need something like this. And again, that's wrong, but we'll get there. We got to hold this connection like tight here. So again, this is all, I'm really hacking right now until I figure out where I want this to really go. But one could argue at least wait group dot, maybe add 3 and wait group done. And then we got to return the,
and that's going to hold those 3? Those
oh,
3
not done. This is wait. Sorry, wait. Yeah, this would hold until that wait group got back down to wait group dot. What is going on here? I got a sync, I got an add, and then those would be dones, and then I have a wait. There we go. I don't know what I did wrong here, but we'll see it in a second. And then ideally these would be doing dones. I don't know if we end up like this just yet, but I just want to play with this a little bit here. Again, this would need to be a go func, let's say. And that would be a done there. And then, yeah, I need a for loop here. Let's just say. This is Copilot causing me pain. Again, it's fine if that's red. I'm sort of okay with that just now because these things don't exist. And again, this would have to return. Can't return errors here, right? And we'll deal with that. I don't know what to do with that yet. But this would keep everything from shutting down until we're ready. And if we separate the idea of ping, read, and write, that gets super interesting to me.
Okay.
So, and even like this ticker here, since it's associated with this go routine, can sort of be put there. But I think if we went in this direction, all right, we've got the
ping.
This is the ping. This is a reader. This is a writer. And then some event cause all of this to shut down. I don't know what that is just yet.
Okay.
I mean, dropping a socket connection would do that for sure. I'd imagine these would just all start failing and we'd get dones. So we got to test. But what my brain says is that in order to even finish that code, we need this package here.
Yeah.
We just need it. And we got to think about what the API is for this, because for every connection that we're able to upgrade, we'd have to register that connection sort of with this package. Now, we're going to have this WebSocket connection here, but it would be nice for this package to not care if we're using WebSockets or not. That's another good reason to sort of let this do the writes, because maybe later we want to play with SSE or we want to play with something else. And if we sort of assume WebSockets all the time here, it doesn't give us some flexibility.
Yeah.
So
Yeah.
the real problem that we have is I don't know how to associate this socket, say, right? So this socket with Kevin as opposed to with Bill.
Okay, I see.
So we need something there. And again, we wouldn't want people to also be, so I would, so this is what I'm thinking, okay? This is something I think that we're gonna need to do here. So here's the client, here's the server, okay? So we'll do one of these little diagrams. So that's the client. Here's our server. All right. So the client's gonna establish a socket connection.
Yep.
Okay. So here it is, socket. I think there's gonna have to be a handshake of some sort before we do anything. So maybe this says we got the socket connection, and this says
Connection established, or
hello. Says hello. Okay. When it gets the hello message, we're now expecting something. Let's say that we're expecting a UUID and a name. You're going to tell us who you are.
yeah.
And then we send one more message back. Been doing everything capital. We do welcome. At that point, we can then get into our different sort of loops, right? That we're dealing with here. Because now, when a message now comes in from this client, okay, so now we're in the loops, right?
Yep.
So let's just do this for a second. So the next scenario, and we're going to code this first before we do anything else.
Yeah.
I just want to see the, well, literally, we can send hello, welcome, right? Like, but like the next scenario would be some message here that says what? Well, let's just assume that everybody knows each other's UUID,
Okay.
right? How that happens, I have no idea. Okay? So what they're going to have to send then is the UUID and the message. All right? And maybe not a UUID, because that's a UUID is nice only because it's sort of unique.
Yeah.
Nobody else can have that ID. There's other ways we can do that, but for our purposes right now, that's sort of fine, right? If people were authenticating, their UUID could be in the database and all this could happen sort of underneath. Like, I mean, how do you think iMessage is working? There's some unique ID associated with our accounts.
Exactly.
Maybe that's the phone number, right? Or something like that. So we can hard code this in our thing. So that could be a message, right? And that would be sort of one scenario, but we should probably, you know, send back and let them know what.
Received, yeah.
And maybe we go back and we say received. Maybe we don't need to. Maybe it can be really like UDP where you get no sort of acknowledgement that we've done that. But let's just say it comes back and it says received. All right. So then another scenario then is we're going to go, right? we found the person that's there. And so what we'd want to send is the UUID of who sent it, maybe the name, right?
So UUID, name, and message.
Now the question is, we would want to receive some sort of acknowledgement, right? Only because in a more complicated system, which I don't think we'll code at that level here, if we didn't get this received, then we could keep it for a certain amount of time.
Oh, okay.
And maybe send it back or something, right?
Yeah.
So look how that's on my screen here. It looks, isn't that weird?
Oh, yeah.
Oh, wait, maybe because I'm on an angle.
It's because you're
straight.
on an angle.
That's funny. All right, I'm not drunk, everyone. I just, I didn't realize it was crooked because I'm kind of sitting on the side, so it looks straight to me. Anyway, I think these are things that we can do, but we need this sort of initial handshake to happen before we do anything. If we can't get the handshake,
establish the connection, basically.
we're kind of done, aren't we? So this is where I'm like, what do I want to work on first? Do I want to work on the handshake first? Do I want to work on the package where after the handshake, we can establish these sorts of things? I feel like we should do the handshake first.
I agree. That's
right?
like everything kind of goes off of that.
Comes off of that. And so when I look at this, for me, after we upgrade, right, there would have to be this sort of handshake scenario where maybe we pass in C, and if error not equals nil, then we would want to return, again, maybe something like
A message. Handshake failed.
Sure. And I don't know if I want to give them the actual error. Or maybe. I mean, we control it. So maybe we do that. Okay. And then everything else here, from my perspective at this point, if the handshake is successful, it did all of that, then we're sort of done.
Yep.
So I'm just going to comment that out. And then ideally, we want to implement this handshake, right?
Yeah.
And it will be a method here. It's not a route by any stretch of the imagination, but we'll have that. So let's play with that sort of idea here. So
Copilot helping.
Copilot's not, I mean, it's interesting. I don't know how it does it. Again, sometimes it's in my way, but it must be reading a bunch of code where people have done these things 100 times, right? So that's kind of nice. And even this, I'm not sure it's the right thing yet. But okay, so what do we know about what we thought of here? So this stage one is done. Okay. We've gotten a socket connection. We've upgraded it.
Yep.
So our first job then is to send a message back. Let's do that. What are you doing here? Okay, we'll figure that out. And we said that we would send back hello, right? Let's do a fump.errorf, and this will be the right message call, and it's a %w because we get an error. It's not our job to worry about what's happening there. So we do that, but now we're waiting on this read message, okay? Now what is killing me here on the read message, it doesn't take this is an old package, right? It doesn't take a context. We're not gonna wait forever, sort of for this to happen, right? If we don't get it in a certain amount of time, we should be failing here. So we're gonna need a couple of things, I think, to make that happen. One thing that I'm thinking is a context where it's with timeout, okay, using a background, and then let's just say that you've got essentially 100 milliseconds to do that, right? For cancel.
Okay.
So that would, so you've got 100 milliseconds to sort of make this happen. Now, we're also going to need, I'm going to start with a wait group here. I like wait groups. Add one. And then what we can do is do a go function. And we could put this call here, read message. Actually, it might be better to use a channel because I want that message back.
Okay.
So let's try that first. Make a channel of type string. We'll definitely make it unbuffered because we want to get that information. And the read message returns message type. I don't care about that right now. The message and the buffer error. So now that's interesting because if there's an error, then we're still only dealing with a string here, right? And we're inside this sort of go function. So what are we going to do? I'm thinking off the top of my head, right? We can do that. So if this returns and the string is empty, we know there was a sort of error. All right.
Okay.
Maybe. And then if not, does that return a slice of bytes? That's fine. We know it's going to be a string in our case. So we can do that. And then what we're doing here is sort of waiting message, waiting on the channel here. All right. Now that's good. But again, we don't have sort of a, this is going to block forever, let's say. It either blocks forever or it dies because there was some sort of socket drop. All right. So how do we handle the timeout that we're willing to wait here? All right. Well, this is where we might be able to use a select, and we can do that.
Where the context finishes, basically.
Case, and so one could argue that we've got two things that can happen here. All right. Either we get the message back or the context sort of timed out.
Yeah. Okay.
So that's pretty cool, right? If the context times out, then we can just return the error. If this happened, we can almost just do that. Now, if message equals this, let's go negative path case,
Okay.
then we've got a problem here, right?
Yep. The message shouldn't be empty.
Nope. Copilot getting in my way again. So we can do a return from error f invalid message handshake or something, right? Expecting hello, something like that. We're going to clean this code up.
Yeah.
Like, this is ugly, but I just want to walk through this sort of workflow here. Like this, I think we could put in a little function here that could sort of just, do this in an asynchronous way. But
Okay.
it is doing it, right? So what we have now is we write hello. Oh, no, we weren't expecting hello. Here we were expecting UUID and name, right? And let's say expecting the ID and name. So let's just walk through this again. So we're going to write hello. Then what's going to happen is we're going to launch a go routine that blocks to read a message. If it fails, we'll just return an empty string. If it succeeds, we'll get back the message. Then we sort of block here waiting on this go routine to return. If it returns, it just assigns it to message because we need it for the next workflow. Or if the context times out, we just return an error. And at that point, this would shut the whole thing sort of down, right?
Okay.
Okay. And that's fine. Now, even just this alone, we're going to have to read another message again, aren't we? Like, we're going to go back into this whole sort of logic again, over and over again. So what I'm thinking is that if I took this for a second, I'm going to use a function for a minute. All right. Then what I know is if I do this, I want this to block. So if I did this and had it return a...
By block, you mean everything's going to wait until it's done,
yeah,
essentially.
Yeah,
okay.
yeah. So if we did this, we wrote a read message function, right? Then nil could be interesting. And then this can return an empty string. Now, this context, I would pass it in instead of hard coding it. So we can sort of control the timeout context. Oh, that's fine.
Oh, comma.
Yeah. All right. So construct the channel, do the read, sort of wait for that information. We either get an error here or we've got a message. Now, ideally what we could do here too is if message equals this, you know, empty message or something. I don't know, right? If there's an error, then we could have gotten an error. So the thing is, we could return the error and prefix it with the big word error, and we'd know more. We could do this with a struct. So we could just say, if we wanted to be a little bit better, and then say message string error. Okay, let's just say that. Now it's a response. Now here we return a response like that.
Okay.
I'm not good with this Copilot. Right? And then here, this would be a response with message, say nil. Okay. Message is
String.
yeah. So can I use message variable?
Slice of bytes. And string.
Oh, because it's a slice of bytes, right?
Yep.
All right. So we just say, hey, you're a string. Leave me alone. Okay. And then that's kind of cool because now when this happens, what we can do is assign this to be a response. Right? And then if the response dot error is not, see, it feels a little bit more idiomatic now,
Okay.
right?
Yeah.
Nil, then we can do that, or we can just return response dot message. See?
Okay. Yeah.
And not use response, because what we want to know if we have a message or an error. So this gives us a little bit more, some idiomatic sort of really making sure that it's an error as opposed to like the empty string always, it didn't feel right. But if you see this, if this works, right, we now have a way of being able to time out the read call, because given the context here, right, we're going to return. Now, the bad thing, if somebody's watching this, they're probably going, yeah, Bill, so you get out of here, but this go-routine continues to, actually, we've got a go-routine bug here. This go-routine continues to live, and because you're not there on the receive, you're actually going to leak a go-routine. When this was an unbuffered channel, okay, that means that there has to be a go-routine in a receive state in order for you to send. So if we timed out and we left, and then this finally returned, we would be blocking here because we're not listening anymore. We're out. We're leaking go routine after go routine after go routine. The quickest way to fix that go routine leak is this. So now it's a buffered channel. This gives this send operation an absolute way of doing a send. So we had a bug. We had a nasty little go routine leak sort of happening because once we returned early, that went away. There was nobody there to receive.
Yeah.
Right? It's like me wanting to hand you something and you've left the house already.
Yeah.
And I'm like, shit. But now what you did is you said, here's a box. So if I'm not here,
just
put it in the box and we're good. And that's what we just did. We added a box.
Got it.
So this is going to place it in the box now. If we're here or not, it's irrelevant. So we were setting up for a nasty little bug there. But what's nice about this is now we can move on. There's no way to stop this from happening. Okay, unless we want to drop the socket connection ourselves. So what we could do is if we end up here, we could close and just shut the whole thing down and say, hey, you took too long, so guess what? We're done, right? We're going to close it, and then we're going to return an error. That will allow this. That should immediately shut that thing down. Yeah. Let it send. I don't need to wait for it. One could argue that if it times out and that closes, then why don't we wait for this go routine to complete? I know it's going to happen at some point. It's not important for the response to come back. Now, it wouldn't be bad to have some logging in here later so we can sort of test this, right?
Yeah, and see if it's really...
We can test it. So, did we pass the logger in here? No. Right? We're going to need our logger in here because when you're dealing with all this sort of concurrency, we're going to want to make sure that we see all this stuff here. So we can pass this in like this, log. We'll do that. We'll fix this here. We have the logger. No, now we need a config here, right? Or we don't need the config just yet. We can just do the same thing. It's one parameter for now. If it gets a little bit bigger, then we can do that. So we can do that. And then we'll come over here. And we do have the logger here already, which is nice, right? So here we can do CFG log. All right. Actually, we needed that at the routes level. Yeah, so we have it there. So CFG is a logger. I used the wrong one, Mr. Kennedy. A logger, which is our package. Yeah. Okay, good. Logger. Okay. And a logger. Okay, better. So, what is it not happy with here? Oh, we didn't return. Yeah, well, if all that, then what are we returning? The message. This is the, handshake is where they're an error now. Oh, so let's finish this now. So hold on. So I'm going to make this a method again. So I've got the, I can bring the logger in. Did somebody ask a question or?
Why no return statement if there's an error in read message?
Why no return? This is inside of a go routine. So there's nobody to return to. What we have to do, our return becomes a send on the socket. because we're in a go routine at this point. And we're in the go routine here because we can't time this out any other way. We don't want to wait forever on this. So the idea is this goes off in its own. Essentially what we're done is this. This is our go routine here. We only want to wait a certain amount of time, right? So we're only willing to wait, let's say 100 milliseconds, that's it. So there's no mechanic built into the API for that. That's fine. So we launch another go routine that will then block on the read message call. So this will perform the read message call, right? And that can take forever if we don't care. And if it does, whatever, because in 100 milliseconds from now, I should move this sort of up here, right? We say we're going to wait 100 milliseconds. We sort of wait. If this doesn't return in time, we keep going. Okay. Right? We don't stop. We just keep. We wait 100 milliseconds. We keep going, which now means that we've sort of, at that point, orphaned off the go routine, right? Because we're gone, right? At that point, we're gone. Now it's an orphan. We don't care about it anymore. We asked you to do something.
And you didn't do it.
I was waiting 100 milliseconds. You didn't do it. I'm moving on. Okay. But to manage this thing, this is where we needed the buffer here, because when it does return, it's going to want to send on that, and then it can terminate and go away. That's fine. And we throw away the response. But there's no way else to do it here because this doesn't take a context. It doesn't do it sort of for me. These older Go APIs are going to be like that. So to answer your question, this is the return right here. And we're guaranteeing the return because we're using the buffer. All right.
Got it. Okay.
So either we're going to get an error here, we get an error here, it's nil, and we actually have the message that sort of came back. That's our read message there. So if I go back to handshake for a second, the idea now was to use, but I wanted to add some logging, so that's why I did that, right? Yeah. So one thing I like to do when I'm creating these Go routines is a.log.info context. Maybe the message is starting read, starting a handshake read, right? Defer. We're going to need to see this stuff, especially early on. Started. I do like a completed, right? So we'll know that this thing terminated eventually here. And then if we come back to this for a second. So at this point, we want the read message call, right? There's our context, 100 millisecond wait. And there's our WebSocket.
Yep.
And this can return a message or an error. And we'll do it this way. If the error doesn't equal nil. So what's nice now is all this code got sort of moved, right? Yep. Into a simple sort of read message call. And then if this happens, let's see what Copilot wanted to do. That's fair, right? Like,
write message, read message.
Yeah, that's fair. How nice is that here now, right? All the complexity of the sort of concurrency we sort of tuck away. You want to keep all the concurrency
in one spot
always together too, right? I don't want to really don't like the idea of moving channels around and things. That's where you have bugs. If there's a bug here, we've got one place to sort of look at it.
Makes sense.
Ideally, there may be a new WebSocket package out there today that handles timeouts and stuff. But for what we're doing, this is good learning exercise.
Exactly.
So to get to play with it here. So assuming that the read worked, we need to validate that we sent a hello. We're expecting this. Now, question, do we want to expect this in JSON or maybe just like that, comma delimited? Or since a name could have spaces in it.
It could have spaces.
Right? It could be UUID and then everything else, or I think if we did JSON, it would just be sort of cleaner. What's the big deal? It's our little protocol, right? At the end of the day. So we could do the following. We're expecting a UUID and a name, correct? So what if I did for now, I just put the type here, right? So we could argue that this is the, let's just call it info for now. All right. And like we said, there's going to be a name, a UUID, right? Or just call it an ID. I think we can call it a UUI. I think this would, I always use strings at this point, but let's see if it marshals properly. We do that. And then at that point, we can do a JSON dot unmarshal. You see, this is where unmarshal. The data is that message.
Yep.
And the any is the we need a variable of this type. So what we can really do is just say, instead of type, I can say var info struct, and then I can say the address of info.
Oh, okay.
Okay, now unmarshal, funny enough, wants what? A slice. So now
slice,
we're going
yeah.
back and forth with slices. So what should we do here? Let's just return the raw sort of slice back out. And we make this a slice of bytes here, right?
Okay.
There's no reason to be doing these conversions over and over again. What's also nice by using the slice is we can then use nil for that. So that's kind of cool.
Okay.
And now that just sort of works, right? So we can do the JSON on Marshall if error, oops, sometimes I hit the wrong keys. If error not equals nil. Now if that fails, why not? I'm good with that right now. And that should work. And assuming it works, we're now sort of here. So now it's a matter of welcome. Now, what's nice is if we define this more as a model, okay, maybe we call it a user. Okay, we can keep it unexported. We call this a user. Come back here and say you are a user. Then we can return user and an error as part of the handshake, right?
Yep.
How nice is that?
That's better.
Yeah. Well, we didn't know that a few minutes ago, right?
Oh.
So I can just call this user, and we're going to return a user and a nil. And you're going to do the address of a user. So now this handshake function's pretty nice. We still have to do one more send though, don't we? So if all that works, we said that we would write one more message that was welcome. Now, maybe what would be more interesting is if it was welcome name, right?
Yeah.
So the best way to do that maybe would be, just call it V for now. Sometimes when I don't know what I want to call it, we do a .sprintf, and the format can be welcome %s, and the %s then is the username. We'll see. I don't know. I think it, even though it's a slice, I think it will be. Oh, it's a string, so we're fine there. So that's beautiful, right? And then this could just be a V. Now we could just, but it wants that to be a slice. No big deal. So
string or byte. Yeah.
No big deal. I'll just convert it that way. And that's sort of clean. So welcome. Now welcome with the space is enough, and on the other side we need to just make sure we get a welcome. It's nice that if it matches the name, then we know we don't have other bugs. And then we send that user. So this is kind of cool. We've got a read. We've got a handshake operation that completes from beginning to end. Handshake now sends a user
Yep.
and or an error. If I can't put the if there anymore because I need the user,
Yep.
right? And then what we can do right now in Connect, because after the handshake, it's at this point it would just drop, but we can just do a.log info handshake complete user, right?
Mm-hmm. Yeah.
And let that all sort of die at that point. Dude, that would be pretty cool if that sort of handshake thing sort of worked. So there's a lot of code there. We can't test it just yet. We're going to have to build a small client right now that tries to implement the handshake. It could be something we're going to throw away. I don't want to, we could do it with a test actually, because we could use a test to, bring up our little server. In other words, we can write a test instead of launching this and then doing something else right now. There's two ways we can do it. I could go under API tooling and start building out a client, which we kind of need anyway.
Okay.
Or we could build a test that brings up our router and starts doing things. But we're going to need our little client anyway, right?
Yeah.
I want to push this code up, at least where it is right now. So let's do the following. Everything is saved. Let's do we're going to have some new files.
Yep.
Git add all, bop, git commit minus, we'll just call this the handshake code. I don't really care. Push. So at least we've saved a commit of that right now. What time is it? Okay, we got like 20 minutes left here. If we could get the handshake working in the next 20 minutes, at least that's a good sort of logical breakpoint, right? So now we're going to be hacking here completely. Like, I don't care about any of this code per se right now. The last time I worked with the WebSocket stuff on the blockchain, I think, did I have a little CLI tool, but I don't know. No, that doesn't connect. It wasn't a game. I had the game in, oh no, this was blockchain. You know what we should also be looking at is not blockchain, actually. Let me bring up another project. The Liar's Dice might have it. Let me look at the Liar's Dice real quick. On the Liar's Dice, I think we're using WebSockets there. Maybe interesting here. Yeah, you see established WebSockets, and there was, well, I don't know what VS Code just did.
That was weird.
Yeah, it's never happened to me before. That was weird. There must be some package called engine somewhere. App CLI. Oh, yeah, right here. Okay. Dude, I don't know what that was. That was wild.
Yeah, I've never seen that.
No. So actually, this was the project we should have looked at here, right? Because with the events, this is now sort of in a receive. So here it is. This is what I'm looking for. Let's steal this code here. So I'm going to shut off blockchain for a second. Liar's Dice had some code that I wanted. Again, we're just hacking here. In fact, let's just call this hack 1, right? And then we can return an error. And then we can just do a basic if error colon equals hack 1 for now. I don't like the idea of a panic, but we can do a log dot fatal error, and that's good enough. Again, we're programming here a little bit. We know we need the Gorilla WebSocket because that's what we're using. Oh, we already have an import there.
Yep.
Boom. And if we can do that, we'll see it. We have that. Now the dial needs a URL and a request header.
Mm-hmm.
So the URL, I'm guessing, is going to be our endpoint, right?
Yeah.
In fact, like we can do that with a constant, right? And if I go back to our make file, this was this, but it's that
connect
and
now.
connect, right?
Yeah.
Okay. And then the dialer needed a request header, but we, where were we here? Events. We can make one just like that, I guess. That's fine. Okay. And then we have a socket, don't we? So then with the socket, what did I do with this code here? I have a teardown function. There's a go routine. It sort of loops, but we don't need to do that. We need to like hard code almost the same thing that we did before. So let's just sort of hard code it right now. All right. Defer socket close. So as part of the protocol now, we've done the dial, right?
Mm-hmm.
The dial establishes the socket connection.
Okay.
So at that point, we've done this. Now it's supposed to get back a hello. So just to keep things simple here, socket.read message, right? We can, again, hack this all we want. The read message takes nothing, but it gets a message type, which I don't care about right now. It takes a, if I do that, you're not going to give me my IntelliSense. Okay, message type, the data and an error, right? So say a message and an error.
Yep.
And if there's an error, then we can call socket, right? Just say read for now.
Mm-hmm.
We expect after that had said hello, right?
Yep.
So if, look at that.
There it is.
That's crazy.
Yep.
So we don't get that, we get that. Then at that point, we're supposed to send back some JSON, right?
Welcome.
Right? We're supposed to send back some JSON for this. I'll just do that, even though that's not JSON, with the UID and a name.
Mm-hmm.
So what we could do, we're supposed to get this back, right? User information.
Yeah.
So var user struct. We didn't put any JSON tags on there, so the capitals will be fine for what we're doing right now. So the ID would be a new UID. Name would be Bill Kennedy. Okay. Oh, I don't want var there. UUID. Give me a GitHub. Thank you. And now we've got that. Now we need a JSON Marshall user. Okay, we've got that. That returns a, let's just say the data and or an error.
Okay.
And if that fails, I'll just steal this. Marshall.
Yep.
Fine. And then we've got the data. At that point, we sent that. Now we're waiting for welcome name, right?
Yep.
So then we'll do another read. That's fine. And then we can just do a func.print line string message, hopefully. So, oh, the data though, we had to send the data, didn't we? Hold on. We missed that. We missed this part, the send first. So once now I have the data, I've got to do a socket.
Oh, okay. Yeah, I see.
That's why it's nice to have these little diagrams you can go back to, right?
Yep.
Write message, man. Just give me a right message, man. What is the message type that we're using on all this? I can't remember. I think the WebSocket had message types. Message types.
Text message?
Text message, yeah. Perfect. Then it's the data. And then, see, this has like, oh no, it doesn't have a deadline. I don't know where that came from. And then that can either be an error or not, right?
Yep.
Oops, sorry. I don't know how I ended up here. Happens to me. Error not equals nil. That's fine. Then we go back into a read, yeah. Okay. So if we were to look at this for a second, again, we're just hacking here, but
yeah.
So there's the socket connection there. There's the read. We expect to get a hello.
Yeah.
There's the send. And then we're back to the read. And then that should all sort of terminate. And we got to, this is a good little program because we'll be able to experiment with things shutting down early and all that stuff and make sure that we're handling this stuff sort of out of the box. So this is crazy. This might work. If it worked, like that would be really silly. Really, really silly. But let's do the following. I'm going to push this up, even though it's not going to work, and everybody that's watching is going to try it immediately. But it is what it is. So did I have to add anything? Git commit, first handshake try, right? Okay. So first handshake try, man. It's going to be crazy. So, I need a make for this client, don't I? So I'll just do a copy relative path. I'll add it here too. So this is going to be our chat
client.
I'm just going to call it hack for now. And it's going to be a go run, right? I'll push that later, but make chat our hack. Dude, I have no idea what's going to happen. This is like when my stomach hurts. I don't want to see it all blow up, but. Okay, so malformed. Oh, we have to do WS on the protocol, I think. WebSocket, I think. Let's go back and look at, yeah, look, replace
Oh, okay.
with WS. So let's see if that works now. Holy. Woo! Dude, that's crazy right there. I mean, I want to add some more logging too, man, but you can see that the go routine started and completed. And we can see the handshake completed and then the request. Dude.
That's pretty good.
Man, that's the way to like close the show off. So, yeah, that was stupid right there. That was stupid.
That was cool.
Okay, so let's add some notes now. And then I'll push those notes up with that other change here. But that is wild right there, man. Yeah, that is wild. But let me add some notes first, and then we'll do what he's asking here. So let's go back to where we are sort of right here. I'm going to leave, that code's not going to stay like that.
Yeah.
But I don't want to sort of lose it. So we still have some things here. I'm going to leave that list up, and then we'll clean it up a second. So let's leave a note that we have the handshake working. Okay.
Yep.
Okay. So we want to test sort of some handshake errors. I think it would be good here to like put some pauses in, make sure the timeout's working,
See
all
exactly
of
how
that
it's
too.
behaving.
Because I think if I go back to, yeah, anytime in the handshake, we did a read, we read the message, and then we said welcome. We only had to wait that one time, right? And the client side, which looks like I didn't save or something. I'll push this in a second. Oh, I didn't push up the WS for everybody.
No.
Let me do that then. Just get status, get commit, WS fix. At least everybody has that. We needed the WS there. On the WS side, yeah, we connected, we read, we wrote, we read, but that's the client side, so that was good. So we can put some pauses in there and test our timeouts and stuff, right? So want to test handshake errors, including the server timeouts. So I want to do that like first thing. Then, once we know that's working, then we need to we got to work on the router package, right? And the router package is able to sort of map a socket to a user,
Okay.
and then and then yeah, we're gonna be able to at least do all that, and then we can come back in here, and once we have the package, and then essentially we can sort of finish this code right here. So that's kind of where we're at now. Next week, let me push that up too. Git commit -am updated notes. Okay. So we've got that there. Let me kill this. This doesn't need to be running. Blah, 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 blah. Okay, cool. So if I come back here for a second. So next week I have training. I'm training in that service class from 8 a.m. to noon. It would be nice to do this again sort of next week, but we wouldn't be able to start at 11. I think we'd have to start at like 1 o'clock. So I think what we're going to try to do, I'm looking at my calendar here, yeah. A lot of people are in Europe and overseas, so doing something at 2 is kind of late. But you'll have the video, so we'll be able to do that. So I think what we can do is I finish at noon, so do this from like 1 to 3.
Okay.
Which would be kind of like starting now,
Yeah.
right? Because it's about 1 o'clock. So Tuesday, Thursday, we'll do 1 to 3 because I'm in training, and we'll continue to sort of knock out where we're at there. Somebody did want me to explain. Let's see here, back to this, and oh, I need the diagram, right?
Yep.
Let's close all this up.
Inside chat.
Yeah, inside chat, of course. Now, can you open the diagram where you explain the workings of the Gorilla Mux, as I want to take a SS. I'm not sure what it is you want me to explain, because this isn't really Gorilla Mux stuff as much as what we're going to try to implement when we get back here on Tuesday next week. So what I'm going to say to you is, and this is for anybody, honestly, if you have any questions, you have this code that we've written here. If you have any questions, just send me an email, bill@ardanlabs.com. I'm writing it in the chat again. And I'll try to answer that stuff. But, dude,
Yeah, that was
I'm pretty happy with where even that code is. Like, even the functions we wrote, it's pretty... I don't know if there's much refactoring we have to do. We'll read it again when we start, because you lose 20 minutes getting your head back in the game.
Yep.
But I think the code is actually in pretty good shape right now. Once we start like killing clients early and things like that, we'll find some stuff.
We'll find the whole.
We might. I mean, we've written this code before, so it should be clean. But And we'll review that. But I'm real happy with where we are. Just the fact that the handshake worked.
Yeah, that was cool.
That was pretty good. Because now it lets us
First
get
try.
to the next thing. Okay, dude, it's 1 o'clock. So we're going to sign off here. I hope everybody enjoyed this session. And Kevin's going to have that. What do you want me to press from?
No.
Oh, Kevin's going to have all this stuff up, hopefully early next week.
Yep.
And then you'll see next week, we're going to do from 1 p.m. to 3 p.m. Eastern time because I'm in training. But we won't miss the 2 days. So hope everybody enjoyed it. Create some buzz on social media, Blue Sky, Twitter. Send me emails if you have questions. Appreciate everybody being here. See ya.